Greetings, I'm Squared here, and we are going to talk about coordinate geometry. Now, for coordinate geometry, we have to know these three formulas. You've got to have them memorized: the slope formula, the distance formula, and the midpoint formula. So the slope formula, remember, that means all of these subscripts mean an x or y coordinate. So x sub 1 comma y sub 1 is a point, and so is x sub 2, y sub 2. Those are points. And so if you have 2 points, you can find the slope between the 2 points, you can find the distance between the 2 points, or you can find the point in the middle, or otherwise known as the midpoint. So you use these to prove different things. So let's go over when we would use slope. We would use slope anytime we're trying to prove lines parallel or non-parallel, and anytime we're going to prove things perpendicular or not perpendicular. Perpendicular, oh, I can't spell it. Anyway, you know, perpendicular, which is right over here. We're going to do that. There it is, pendicular. I wish I could spell, but it just didn't happen. Okay, distance formula. You're going to use that to show things are congruent or not congruent. That's what you're going to use. Distance formula. Midpoint, you're going to show it, you're going to use it to find the midpoint, but if you find the midpoint of two things and they're the same, two different segments, that means they bisect each other. So to say that again, if two segments have the same midpoint, two different segments have the same midpoint, then they bisect each other. So sometimes you're asked to prove that something's a parallelogram. Well, there's lots of different ways you can do. You can use any formula to prove something's a parallelogram. You could use the slope formula to find the slope of all four sides and show that opposite sides are parallel, because remember, parallel lines have equal slopes. You could use the distance formula to show that all opposite sides are congruent. That means it's a parallelogram. Or you could find the midpoint of each diagonal and show that they're the same to show that diagonals bisect each other. Any one of those would prove something's a parallelogram. So those have to be memorized. We're going to use those every single time. So it's really important that you look at the problem and think, okay, am I proving something congruent? Then I'll use the distance formula. Am I proving something parallel? Then I use the slope formula. So let's recap about parallel and perpendicular. Parallel lines have equal slopes, and perpendicular lines have negative, or sometimes we say opposite reciprocal slopes. So if this slope was 2/3, the parallel line would have the same slope, but if I had a slope of 2/3, the perpendicular line would be the opposite, which means if that was positive, this is negative, or if that was negative, this was positive. And then you flip it over. Reciprocal means you flip it over. So those two slopes would show me that those are perpendicular. Okay, so it's asking what kind of triangle is ABC? Use formulas to show your work. Okay, well, it kind of looks like a right triangle to me, so I'm thinking the first thing I should do is find my slopes. So although we have the formula, I would love to graph it anytime I can, because if I can graph it, the slope is so much easier, because all I have to do is count down and over. So that's 1, 2, 3, 4, 5, 1, 2. So I went down 5 and over 2. That means the slope of this side is -5/2. What's the slope of this one? Well, I know if it's perpendicular, it's going to be 2/5, positive 2/5. So I'm going to go up 2 and over 1, 2, 3, 4, 5, and what do you know? The slope is 2/5. I have just shown that the two adjacent sides have negative reciprocal slopes. That means these two are perpendicular. That means that's a right angle, which means it's a right triangle. So what I'm going to do now is I have to explain that in words. So I would say the slope of, and then I'm going to use AB, is -5/2. The slope of, what is it, BC, segment BC, is 2/5. They are opposite reciprocals. I'm going to abbreviate. And then I use this little 3 dots in a triangle. In math, that means therefore. Therefore, the segments are perpendicular, and triangle ABC is a right triangle. Now, this work is important, but this is the most important thing. How do you know what kind of triangle that is? And you have to show in words what you did and then explain your conclusion. Okay, what kind of quadrilateral is RSTU? Again, well, it depends. It looks like a parallelogram to me. So what do you want to do? Do you want to use slopes? because we could use slopes to show that opposite sides are parallel. We could use distance formula to show that opposite sides are congruent. Or we can use diagonals to show that the midpoint is the same. Let me look at my next one to show. Do I do any midpoints? Okay, then I'll do the midpoint on this one because it doesn't look like the next one's going to be a midpoint. I should plan ahead, shouldn't I? Okay, so I'm going to find the diagonal, the midpoint. So I'm going to write here the midpoint of, let's see, RT. What's the midpoint of RT? Well, to find the midpoint, I add and divide by 2. So the x's are 1, so 1 plus 8, that's 9, and 5 plus 4, that's 9. So my midpoint of RT is 9 halves, or 4.5 comma 4.5. Okay, you can write it in decimals or fractions, it doesn't matter. And now I'm going to find the midpoint of SU. So again, my midpoint is always an x and a y separated by a comma, always divide by 2. So what's 2 plus 7? 9. What's 8 plus 1? 9. I just found out that the midpoint of RT, one diagonal of the quadrilateral, is the same as the midpoint of SU, the other diagonal. So I would say the diagonals of RSTU are, bisect each other. And how do I know that? Because they have the same midpoint. Same midpoint. Therefore, remember my little triangle, RSTU is a parallelogram. Now, I might also want to say something about it not being a rectangle, but I think you can kind of see it. But if you wanted to use slopes, right, this slope right here is 3 over 1, and this slope right here is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 is 2/3. So it's definitely not perpendicular. So I just might show that over there in the work, and then I know that it's not a rectangle. So if it looked like a rectangle, I might want to not use the diagonals or perpendicular, but use slopes. Because if I use slopes for all of them, I would show that they're parallel and perpendicular at the same time. Obviously not the same lines. Those would be parallel. Those would be perpendicular. Okay. So what kind of triangle is ABC? Show your work. Did I just do one like that? Is it? Oh, it's a little different. Oh, and it's not a right triangle this time. At least it doesn't look like it. It could be. Let's see. Okay, so what kind of triangle is it? Let's find the slope. So that's 2 up 2 over 3. But I went left 3, so the slope of this side is negative 2/3. What's the slope of this one? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, so 6 over 4. That would be 3 halves. So we get a 3 halves and a negative 2/3. I guess it is a right triangle. And so what would I say? I would say the same thing I said over there. The slope, I'm going to use M for slope this time. The slope of XY is 3 halves. The slope of, what do we got? YZ is negative 2/3, right? They are negative reciprocals. I'm not going to write the rest because it takes too much time in the video. They are opposite reciprocals. Therefore, this triangle is a right triangle because XY is perpendicular to YZ. Okay, so when I look at that, definitely looks like a trapezoid. But how can I prove it's a trapezoid? What kind of quadrilateral it is it? Well, to prove it's a trapezoid, I have to show that 2 sides are parallel and 2 sides aren't parallel. So I'm going to find the slopes of all of them. So I'm going to find the slope of BC, the slope of CD, the slope of AD, and the slope of AB. Okay, so 2 and 3, so that's negative 2/3. And then this one is positive 1/2. And this right here is down 1, 2, 3, 4 over 1, so it was negative, so that's just 4. And this one is up 3, 1, 2, 3, 4, 5, 6, so that's 1/2. 3 over 6 is 1/2 as it's reduced. So now do you see that 2 slopes are the same? So you could say RSTU is a trapezoid because the slopes, so I'm just going to say it. It gets too busy to write. The slopes, I'm going to use that for slopes. The slopes of BC and AD are congruent, and therefore one pair of opposite sides are parallel. You'd have to say one pair of opposite sides are parallel, and that makes it a trapezoid. That's your reason, and this is why you know that they're parallel. Okay? A network of roads connects 4 towns. Find the total length of all the roads. The side lengths of each grid square is equal to 1 line. Is equal to 1 line? I think that might mean 1 mile. That might be a misprint. Okay, because it says find the total length. I don't know. Let's go. So I need to find this distance. So I like to just count up and over, use the Pythagorean Theorem. So 1, 2, 3, 4, 5, 6. That's a 6. That's a 2. So 6 squared. Remember, a squared plus b squared equals c squared. So this AD distance is going to be the square root of 36 plus 4, which is 40. And now this one is on a horizontal, so I don't need to use the distance formula. I can just count 1, 2, 3, 4, 5, 6. So DC, if it's on a horizontal, please don't take the time to use distance formula. You'll get 0 and then 6, and then you'll square it, and then you'll square root it. So it's really better to just do it that way, just to count. And so 1, 2, 3, 4, 5, 6, 7. 7 down and 1, so that's the square root of 49 plus 1, which would be the square root of 50. And that was CB. Oops, I shouldn't have put that there because I'm doing distance. And then this one is 1, 2, 3, 4, 5, 6, 7, and 1. So that's also the square root of 49 plus 1, which is 50. Okay, so it asked for the perimeter, or the total of all of them. It did not say that I had to round to the nearest tenth. So if I do the exact answer, I'm going to get 6 plus 2 square roots of 50 plus the square root of 40. Now, if you simplify that, some people might want you to. That's 25 times 2, so that would have been a 5 times a 2. That would have given me a 10 radical 2. If I simplify this, I get 2 square roots of 10 plus 6. None of those are combinable. And if it was in miles, then I'd say miles. Now, obviously, we'd use a calculator and round to the nearest, tenths or whatever we needed to if we were needing an approximation. But that is the exact answer, and I know a lot of the problems in the book were asking for an exact answer. So just keep that in mind. Okay, find the exact area of a rectangle with these vertices. So first, what I do is I would actually graph them. So I'm going to get a different, like a little highlighter, and graph the vertices. So negative 1, 2, that's my A. 1, 5 is B. 6, 2, 1, 2, 3, 4, 5, 6, 2, and then 4, negative 1. So here are my vertices, and it looks to me like that's a rectangle, which is really nice if it is, because the area of a rectangle is just length times width. So I can check this out. This is 3 halves is my slope, and this one up 3 over 2, and this one is negative 1, 2, 3, 1, 2, 3, 4, 5. Looks like a negative 3/5. So the slope formula is nice because it tells me 1, 2, 3, 1, 2, 3, 4, 5. That's a problem. And then this is 1, 2, 1, 2, 3. You know why that's a problem? Because those are not perpendicular. So how are you going to find the area of that? I just want to make sure. This is a negative 1, 2, a 1, 5, a 6, 2, 1, 2, 3, 4, 5, 6, 2, and a 4. 1, 2, 3, 4, negative 1. Well, that's interesting. How are you going to find the area of that? Well, if it was perpendicular, then we could just do length times width, but that is definitely not perpendicular. I think that I messed up when I did one of those numbers, those coordinates. So I'm going to pretend like it would be perpendicular, like it would be. It says the area of a rectangle, right? So obviously I meant it to be a rectangle. So oops on that. So we're just going to pretend. It's not, but we're just going to pretend. If you were pretending, like I am, you would find the distance here. Well, you already have the x minus 1, x minus 2, x sub 1 minus x sub 2 here. So the distance here is that a squared minus b squared, so that's like a 2 over 3. So your width here is going to be the square root of this, which is 13. And then your length would be 25 and 9, which is going to be 34. And then you would just multiply those together. Square root of 13 times the square root of 34, which isn't pretty. You could actually do that in your calculator, but it's not going to be any prettier. But this is the area. And then same thing for the area of a triangle. You would plot these points, but it's half the base times the height. Let's hope I didn't make a mistake on this one. I need to remember to change that in my notes. Okay, 2, -1. Okay, let's find the slope of each side. So 1, 2, 3, 4, 5, and over 1. So this one is -5 because I went left 1, and this is 1, 2, 3, 4, 5, down 1. So this is 1/5. So those are perpendicular, which is what I needed up there, what didn't happen. Okay, so these are perpendicular. So how do I find the distance? I showed that it's a right triangle because that's what I need to find the area, is that the base and the height, and those are always perpendicular in a triangle. So I need 1/2 the base times the height for my area. Well, that means I need this distance. Well, I have the two parts I need. So it's the square root of 25 plus the square root of 1 on both of those. So it's a square root of 26 times the square root of 26. And you can find the distance formula with these too if you want to. And when I say 26 times 26 square roots, I get 26. When I divide by 2, I get 13. So the area of this triangle is 13. So that's Learning Target 1, and I'll be back with another video for Learning Target 2. Good luck. M Squared signing out.